Hello again. This is Al, and this is my tutorial series on C++. And right now we'll be going on to number 56, I suppose. This is not really a lesson. And I'd like to move on to the topic of virtual functions, or if you like, polymorphism, or whatever the various buzzwords are, but virtual functions anyway. So I had to pause there. Yes, abstraction. The word I keep wanting to say, and it didn't pop into my head. In order to enable us in this pursuit of understanding what virtual functions are, I'd like to do it kind of manually, without using any new keywords, just from what we already have. And in order to help us with that, I've invented a little function here, which uses this function, which comes from the Dbghelp library. This set of functions in there, they're defined in this file and contained in a particular DLL called Dbghelp.dll. This actually gives me an opportunity to show you another keyword, a directive, Pragma directive, which is very useful. First, if I want to use this function, this is what I want to do. I want to print it out. But instead of using the macro, let's just type it in by hand. Suppose I want to print this out. Remember before I told you functioning wasn't that good because it didn't give us all of the detail. And what I'm getting here is an unresolved external symbol. And the reason is I'm not including the appropriate lib. Now, let me put this back for a minute. I don't need the space just yet. What's this one? Whoops. Together. There we go. Yeah, unresolved external symbol, and that's easy to fix by simply going to the help file, and sometimes it works, and it tells you which particular lib file. Now this sounds like a static library that we've been using for our other things, but it turns out for dynamic libraries, things called DLLs, which are similar to lib files, except that the code doesn't reside in the lib. It resides in a different type of file, which can be loaded dynamically or unloaded. This lib just pretty much tells me the offsets of the various functions inside that DLL. So you go to your project settings and go to, it's already there, linker input, and put that lib file there. That'll make this compile, but it wouldn't work for any of my other. It'll only work for test 1. I have to do that now to all my files that want to use this function. All my projects, I should say. Now there's a way to get around that problem so that you don't have to specify it here. And in fact, you can specify that in the header file right here. I thought it secretly written down here, and it's a Pragma directive, and it goes Pragma comment and then lib meaning import library, and then specify the specific library that you want to include in your link. And now, even though I've removed it, it should still compile. And so will all of the other projects, should they want to use this function. And if I didn't print out the before and the after, then I can do that. Okay, so first let me run it. Not going to be very interesting in this case because it's not a C++ function. Let's make a C++ function. Let's say it takes a string, a constant, string reference. Okay. Do the same thing there. And I don't need to use this string value. I'll leave it in the list so that we can see. And call the function. Now I gotta pass it a string. Good enough. Missing semicolon, true enough. Okay, so this is a voice C style function called foo, which takes as its argument a class TS string constant reference to. It is true that in fact the const here can be written after the variable name and before this. Most people like to write it the other way, but this is what this says is that this is a reference to a type of TS string which is constant. The reference itself is neither constant or not. It doesn't really have a const or non-const modifier. You can't change a reference value as you've seen before. But in particular, I should not be able to modify stir. This should fail to compile. Not allowed. And so that's what that modifier says. It should still have the same printout. But I usually put the const on the other side. I don't know why. I just find it easier to read. To me, it looks like a constant this, constant that. If this were a pointer, this is a slight diversion, but a little bit important, then definitely what the const is referring to does matter. This could be a pointer to a string, let's say. Now, this, as before, should fail. can't compile it because, well, of course, I would need to pass this address to us. Okay, so the error. Okay, that's a non-standard extension. I don't know why this is not a standard extension. In order to make this an L value, which is what it wants, I can do the easy trick, just assigning it to something. Okay, now the error is correctly where it should be. I'm not allowed to modify the contents of stir, but stir itself, I can modify the variable itself. Let's say that let's equal that. That I can do. It's got no problem with that. And that's fine as well, because that's not modifying p_stir, the thing that was passed in. This pointer is a copy of the pointer that was generated on this line, and so even if I had done that in a separate line, if I had done this, S would not, by the time this finishes, first I'm going to prove that p_stir at this point is not pointing to the letter J, pointing to that funny name that we saw before, except now that's a star thing. However, my S was perfectly safe, because all I've done is, all this does is take a copy of the pointer and copy it onto the stack, pass it into foo. Foo modifies the copy, but can't modify the contents, so this is safe. My S is safe in terms of this function call. Now this becomes the way that it's supposed to be written becomes less clear. See, now it looks like that const is modifying the star. That is, the pointer is constant, but it's not. It's what's pointed at, what this points at, which is constant in this declaration. If I want to make the pointer itself constant so that I'm not allowed to do this either, okay, how can I do that? Well, I think I would put a const here. Okay. There we go. And so now this const modifies the thing on the right, whereas this, well, I guess it sort of modifies the thing on the right. The contents, if you use it. Now this is why I use type defs for these things. If I do this, I write it the way that I like to write it anyway, and say this is a pointer to constant ts stir, right? Then I can certainly say this. That's a pointer to a thing whose contents cannot be modified. And to make this thing constant, I can put a const here. Now it's a constant pointer. So now this pointer is constant. And again, it won't compile. Const type def different basic types. Oh, this is already defined. Pointer to constant my feature. Alright, so now I can't modify a constant thing, but now I can. But it's to me it's more readable when the type is on the left, and the variable name on the right, and without any stars or ampersands. When you put const in front, when you have const type and then object, that means the object itself cannot be modified. That seems kind of silly in this case. Why would you even declare a copy of something to be constant? And there are occasions when you want to do this, and those occasions would be when you want to make sure that this variable is safe throughout like a long function, and somebody might redefine this to something else. You want to ensure that that doesn't occur, so you put this const here. You don't want to lose track of this position, let's say. Anyway, that's a diversion. Point is, now we have this undecorated name. A decorated name and an undecorator, so that we can see more clearly what the types of things we're dealing with are. Now, first, what I'd like to do is define two types of classes. One I'm going to call a base class, from which other things may or may not derive. The constructor for the base class I'm defining here will be public, maybe not defined here, at least declared here. And what I want to do is okay. Now, before starting out, I just wanted to mention, in case you didn't notice, that all of the icons here on the left have changed their look slightly. And the reason for that is that I've traveled into the future in order to correct a mistake that I made in the past. So this part of the video is being recorded from the future, so that I can make, undo that mistake that I made in the past, and so therefore that's why this setup looks slightly different. This is an old archive of the code as it was when you were watching it. Okay, now I don't know if you know much about time travel, but there's plenty online if you're interested in learning about it. No need for me to go into that. Now actually, let me just forget about this class for a minute and go to something more familiar and understandable. I want to talk about the topic here I'd like to talk about is overriding something. Now, I would like to put the word function here, but that's not really what I want to say is a little bit more general than that. So overriding, let's say, behavior. That's the British spelling, the American spelling. Something. Now, what that something is, could be a function, or it could be a program. It could be one of these classes we've been talking about, or one of their member functions, or something like that. That is the topic I'm thinking of. Where you start out, we have something like our foo here for, which took a string reference. So we didn't use the name, we didn't use the thing passed in. And it did something, whatever. We'd say, I want to, actually, there's something I want to print out. I want to print out the value of this string and the value of this string. Now, undecorated. And that's what this is. That's what this built-in macro is. I'm going to put a line here. Whoops. Decorated. That's why it's got a D. D for decorated. What this thing does is undecorated. And this that thing returns a string type, and we can add strings. And the resulting sum turns out to be something that can be printed. I'll put one more delimiting line. I want to make it look like, oh, I know what to do. So you can put that there. Okay, so that'll do carriage return line feed, turns out, and then a tab, so hopefully that'll look okay. And I'm just going to call that and see if it works. And they pass a string argument. This here, I can pass in. It turns out that there's a way to convert a string into a string, that is a string literal, into a string object. So this is fine. That should compile. And we'll let it run, do its thing. Not under the debugger. Okay. Alright, so now let me just point out first, the way to look at this is, this here is C script. You know, this is a C language idiom. This is something that human beings learn how to type down in order to declare a function with this name. It would be, if it were possible to specify exactly the name of a function, we can't really, because the compiler does that conversion always. Even if you declared something as extern C and tried this, you'd end up with an underscore in front, so that wouldn't work either. So instead, you wouldn't want to have to type this in anyway. You just use the rules of the C language, and that's how you make your declaration, as we discussed already. Okay. Now, so here I have this foo. Suppose I wanted to, it doesn't really have much in terms of behavior, but suppose I wanted to change the way it behaves. How could I do that? Right? That is, could I declare another foo? Certainly, if I declared a function called foo with the same arguments and everything, then it just simply won't compile because I've given two functions the same name, right? Now, there's another thing that you can do, which is this. Because of the fact of this name mangling business, let's say this one takes an int, also unused. I'll let it do the same thing. Because of the way the compiler intermixes with the name of the function the types of arguments it takes, and even the return value, I can, if I want, declare a function that to me looks like foo, same as this, but as far as the compiler is concerned, they're different. If I try to compile this, I should, hopefully, get an error. Because it'll say can't convert from string to int. But I don't get an error. Why don't I get an error? Have I got some kind of setting to my warning them? No, last time I tried to go through this demo, I did a similar thing, except I used similar types. Now I've used an integer, warning level, general. Warning level for string equals, oh, no, there's no problem. Of course there's no warning. Sorry. Right, no problem. This is a string, so therefore that refers to this function. I'm going to run this, and now one thing I could do if I wanted to is recast this string as an int. I could try that if you want. But let me just put an integer value. Set 7 will be interpreted as an int, definitely. And maybe I won't. No, that should be fine. Okay, so as you can see, I haven't overridden anything, right? Foo didn't change. All that happened was I got a new function with this name, and I'm able to call it by supplying the type of argument that this thing requires. This thing, the first call was not a call using an integer type thing, so it used this function. Nothing got overridden or anything. I haven't changed the behavior of what is called in my program foo. Okay, now I'll just want to make sure that you see that you understand that this is in no way any kind of overriding of something. This here is called overloading. Well, no, it isn't even. It's not even called. It's sort of Okay, overloading is fine. Because you see what happens typically is they'll make one function, let's say, to do a common action wherein the parameters vary, but the action is really the same. Like, for instance, suppose the action is adding an entry to a database. Okay, and let's suppose that the database contains more than one type of object to add, right? So you might have who might be add name to database. Okay, and this one, not name, sorry, add to database. That's the whole point of it. I don't have to say. If it's a string, then we're adding a name to the database. If it's an int, we're adding let's say an index to the database. I don't know. We have a database, and the types of objects it contains are either names or indices. It's not a very useful database, but you could imagine extending that idea such that the thing passed in, whoops, I gotta call the right function. The thing passed in might in itself be a structure of some sort, right? For instance, you might have a customer structure and an employee structure, let's say. You might have an inventory item structure, or various types of things that go in the database, and the handling of adding the different types of things would require a different function, right? Like if the database the database wouldn't store the strings along with these things because they're not the same type. But this function would know where to put the string, the name, and this function would know where to put this number. So generally speaking, let's say it might be a structure of some sort. Employee. I don't have these structures, but I'm making up the name. Employee information. Personal information. Okay. And employee personal information, and you might have another function that is the employee's work performance information, also EPI. What do we call it? But it was an employee an employee record of performance. Okay, call it perf. Whatever, right? Now that the whole point of this thing, this overload, what we're doing is we're overloading a named function such that we can call it, we can use the same name all over our code, and the function that gets called depends on the action that we want to perform, and that's called overloading. So that is the right word. Okay, now what about overriding? That is, if you have a function that does something that may have more than one way of getting it being done. Let's suppose let's suppose that we just got the first one. Well, I'll add to database. I'll put it back to string. And we're only adding strings ever. But what I want is, depending on the situation, let's say, I want the function to use a different method. Let's say you have, in your test environment, you have a test database or something, and in the real environment, it's a real database, and in your test database, let's say you don't use a complicated thing like B trees or something. You just use some ini files. Okay, so you have a simple method in your own tiny little database for testing, but when you finally ship the thing to the store, to the customer, you want the code to use a different implementation, right? Now, one way to do that, right? It could be a name or a structure, whatever. I don't even need to cast. That'll convert it properly for me. This is a pointer to a bunch of pointers to strings. Now, one way to do to override the behavior is to do it internally. Like you might have look something up in the registry. So look up in registry. Okay. Situation in registry, and then take appropriate action. Those were 2 steps. So this is internal overloading. I just made that name up. Pretty good, huh? So imagine that we've sat down and made a few functions to do with the registry, and then we're just going to make up the names as they go along. They won't exist. There won't be any tests. So I'll call if get reg value database type. Well, let's suppose that might take a reference to a database, a string value, or a database. We've defined a type. Something like that. And let's fail if we can't find it. Do that. Make some assertion in the debug situation so that if it happens in that scenario, we can see why it happened. Something like that. Okay, and then it's switch or if and or whatever you want to use. Switch dt. Right, which is, let's suppose, an integer enum type value. And then you would have case debugging any file. Well, we don't know if it's debugging any file database. Oh, it's a string that we retrieve. No, it's database type, not a string. Something that can be interpreted as an integer. And what we do is we call the any file version. When we return that, maybe that thing can fail. I'm not making that B tree name up. There is such a thing, it turns out. That is a type of database tool that companies use for handling large databases for quick lookups. I think that's how you spell it. Oh, actually no, it's spelling like that. Anyway, yeah, there's no E, definitely not. In the company name, there's a dash, so we put an underscore. No, like that. And the default. Okay. So now what we've done is we've simplified our lives so that the rest of the code doesn't have to keep checking what type of database to use to store its values. All it does is call the usual interface, and the usual interface checks in some standard location what it should do and alters its behavior based on that. Now that is an example of overriding, not overloading. Overloading is a thing where the type of data being passed in is different, right? Overriding is where the type of data being passed in is the same, and the function name's the same, and everything's the same, but if you want to override a thing, what you want to do is take a standard interface and change its behavior. That's what overriding means. Overloading means to overload the name, to take the one name and make it have, because of the way the syntax of the language works, that the name in the C script is not the actual name of the function. You can overload the name, right? Like we overloaded foo back here. Back far enough. And that other example, but the one that we actually tested, the name foo is overloaded. It has different meanings depending on what we pass in. Whereas in this case, we're overriding. There's only one add to database. We can only ever pass in special database structure, but whatever it takes. How about we call this a DB entry, database entry. we can only pass it database entries, and the thing that's changing is how the implementation of the function. But certainly, as far as the outside world is concerned, there's only one interface to working with the database and the entries. And similarly, you would have a retrieve type style function that would take appropriate action depending on some setting. Now you can do that, and this method I've outlined here does it internally. The decision is made after the call. Now there's another type of overriding a function, and it has the same effect essentially, and it really, for all intents and purposes, is the same thing, and that is the statement I'm about to write down now that I was just thinking about how to form like a true statement about what the overriding means or how it's accomplished. And I'm going to write it down. As you recall, overriding the method of overriding, the only method of overriding, not yet, how do I say it? The meaning of overriding is achieved through indirection. How about that? Two buzzwords. As always, will not achieve, let's say, implemented through indirection. That is, there is a level of indirection involved, even in this case, where the same interface is used and a different behavior or a different method is used by adding a level of indirection. This is a level of a second level of indirection in this case, right? That is, indirection is like taking a turn, like just making choosing one or another direction at a fork in a road. Why they say indirection? That I don't know. I don't know what the etymology of this word is exactly, but it amounts to really visually. If you think about it visually, the direction of flow changes, and overriding something is done by allowing there to be one of those forks in the road. So the second way then, in order to do this sort of thing, and you could still do it internally in C, right, as you've probably done before, is instead of looking up a special value, right, in a registry, or may or may not exist, you might call another function that returns to you a method. For instance, suppose this is typically this is the interface, okay? And I've asked someone to sit down and write me a function with this interface that does everything that it's supposed to do, and to supply for me a way to retrieve a pointer to the function that they've written. Right? So I might have at this point, I might say, I have to declare a variable type, and it's a bool. It's going to be a function star tf add database, taking this as its argument, equals get add database implementation. You see what I'm saying? That's also a level of adding a level of indirection. Now I simply call that function. You don't need to know what the function is or how it works. Somebody else is taking care of that. And I can just return the value. So that's another way of adding a level of indirection. Now these kinds of declarations here I've done it through a function. I might have a table, let's say, of these things. Let's turn this into a type def. Dbe, pfdbe. I didn't need that, and I don't need it, and I don't want it. That's it. So there's a type def. And then I might have a table. DB handle or something, right? Equals, and one of them is dtree handler any file. Another one might use the registry, and so on. And I might have an index, well, either globally stored, even passed in. And, you could, if you like, overload this function by adding a second function with the same name that takes an optional handler index. Could be a UN. And then all I gotta do is say, trust that the index is correct, and that can be checked. It becomes something like that, right? Now this is again adding a level of indirection, and in this case the method of retrieving selecting the object that's going to do the work is through an index. One way was through a function pointer, a function call that returned a function pointer, and here I just used an array of function pointers, and we call the appropriate one. You'll notice, by the way, that if you haven't noticed in the past, it really is a little bit silly to say pointer to function. Because all a function really is a pointer. There's no, I don't have to put a star here, right? Because a function already is a pointer. In fact, it's a what this word says, right? What this word is or stands for is a reference to an address. In our assembler stuff, how did we declare a function? Like main, we did this. And then this was just a number. And what was a number? An offset. And what's an offset? A pointer. So what's a function? A function is a reference to a pointer. And that's why it's possible to take the name of a function and assign it to something. If I had, get rid of this for a second. Here, that's our type def, right? Yeah, suppose I had one of these things. Or, no, sorry. Suppose I just wanted to do this. Global add. You can do that. That's legal syntax. Because this here, without the braces, is a pointer. But it's not assignable. Just like a reference, you can't do this. Even if you casted it. And the reason is because it's a reference. It's a reference to a pointer. The other thing's okay. I can assign the value from a reference, but I certainly cannot change a reference. Now, I spent way too much time on that, but it's important for you to understand. Just a minute. Oh boy, did I spend too much time. Okay, what I'm going to do is I'm going to make another video after this one. And but before leaving, I'm going to make this point. Going back to our classes, base. Oh, this has some constructor or whatever. And I have within my base class function foo, as we had before. Maybe taking a string even. Just like before. In these classes, you can put the implementation right in line. Well, that wouldn't work. Here, put func. Okay, there's a function, and it's also, as we know, it's also possible to have another class derived, say, that derives from base, so it is of type base. That might do something, who knows. And now it's possible for me, and it's perfectly legal to write down this. Now, actually, it's better for me to leave this here because I want you to think about this one. And I'm sort of giving the answer away by having put that there. The question is does foo override, does this foo override this foo? Is that an override? That is, if you had access to either of these functions through one of these types of classes, would the foo, the correct foo, be called well, given what information you had? Suppose you had a base B and a derived D. First, question A for your exam. Question A. QA. It even says I can say E.foo. Is this which one gets called, if any? Same question. No, I think you won't have trouble answering this part. This is the easy part of the quiz. Now I'm going to move to the advanced questions, and you should think about these before the next video. I'm supposed to have a function now. I can call my function foo, but I'm not going to do that. Bar, which takes, let's say, as its parameter, well, let's go through various cases, a base, okay, and calls Dbghelp. Whoops. Okay, and foo_bar, which they say derived, and there's that, okay, and now I'm going to overload them. I'm going to overload them. Now we've got everything going. I'm going to do the same with this. Okay, now we have 4 functions. They're all different because they have different names. Right? That's just trickery that the compiler mangles the type and everything in with the name. Now the question is, what difference is, if any, are there between the following statements? First, I have my base here and my derived. PB1. And then 2 base stars. Well, remember that the address of D, since D derives from base, is a base, okay? So there's no ambiguity. I don't even need a cast here. If I did try to cast it, I would get an error. And now let's go derive. Yeah, that's right. PB derived star equals the address of D. PD. Okay. Now D is a base, so definitely the address of D points to a base object. It also points to a derived object. It's also a base star. Whoops, I've written this one. But I've done that already. Address of B is a base star. Now the address of B is not a derived star, so that's all the cases then. I'll call it 0 for symmetry. Now foo takes base stars. Not foo. Bar. Statement 1. PB1 2 and lastly third statement. Something else. You could use references instead of pointers or pointers. It's fine. Foo bar requires a derived, and I've only got one derived in the world here. Okay. So ask yourself about these three statements without compiling and trying it first. See if you can figure out what, or ask yourself what you expect to happen, right? And write it down, and then see if your expectations were true. And then ask yourself, you can ask yourself if this overrides that, okay? Or if it does something else, and if it does do something else, what is it doing? Is it overloading something? Is it an overload? Is it an override? Or is it something else? Because there could be something else too. Okay, I hope this works. See ya. Oops, I almost forgot. I missed there are 6 statements, not 3. Bar of B. That's just address of B. How about 1.1? Bar of I'm casting, this is like address of D, which is a base. So it's not 6. D and address D. It's easier probably for you and me to read it like this. Forget the variables. And that's it. Well, no. There's addresses D. Okay, so there's 6 questions. I don't need that. Okay. Here are 4 different ways to call bar, which takes we have 2 types of bars, and one takes object, one takes pointer. D is a B, so we can certainly pass D along into bar, and we can pass the pointer to D into bar. Foo bars, though, however, only take D's, and so there's only 2 statements we can form for that one. Okay. So that's it. 6 questions to think about till the next time. And now I shall return to the past.